Hello everyone, welcome back to the SQL series. Today we are diving into a very useful object in SQL, the sequences. Whether you are a beginner or brushing up on your skills, this one is for you. So what exactly is a sequence in SQL? It is a database object that can automatically generate unique numeric values. And it is great for use cases like assigning IDs to rows in a table. You can think of it as a number generator that helps keep your data clean and organized. So let's break down why the sequences are so handy. So first of all, a sequence can automatically generate unique numbers. That is, there is no need to manually handle the IDs. Then it's a shareable object. That is, the multiple users and applications can access it. There will be no duplication issues. Then we have the primary key value creation. That is, the sequences are perfect for creating auto-incrementing primary keys. The sequence replaces the application code. It speeds up the efficiency of accessing. That is, you can just say goodbye to writing code to generate the IDs. And then we have the cached values improve the performance. So here, when cached in memory, accessing sequence values becomes super fast. Now that we know what a sequence is and why it is useful. Now it's time to understand the syntax to create one in SQL. So let's break this down line by line. So the first statement here is create sequence schema and the sequence name. So here this is going to create the sequence object. You can optionally specify the schema here. If you don't give a schema, the sequence is created in your current user schema. Then we have start with integer. This tells the database what number to begin with. By default, it starts at 1. Along with this, we have this increment by integer, which specifies how much the sequence should increase or decrease by. So here the integer, if it has the positive value, the sequence would be ascending. And if it is static by 1, it will not allow the negative value where the sequence would be descending. Then we have max value, no max value. So here this is going to set up an upper limit for the sequence. You're going to use no max value if you don't want any maximum limit. Similarly, min value, no min value. Here, this is going to set the minimum value the sequence can generate. It is useful for descending sequences. Then we have cycle and no cycle. If you choose cycle, the sequence starts again once it reaches the max or minimum. With no cycle, it throws an error when the limit is reached. Then we have cache integer or no cache. Caching stores a set of sequence values in memory for faster access. This speeds up the performance during high transaction activity. If you don't want, then in that case, you will go with the no cache, which is the default one. Then we have the order or no order. Order ensures that the values are generated in the exact request order. And this is very useful in the rack environments. In most cases, no order is used as default. We have this option of scale and no scale, which is the provision that is there in the version Oracle 21C and above. And this specifies whether the fractional values should be maintained in the sequences. Then we have shard or no shard. Shard helps generate globally unique values across the sharded databases. Use no shard if you are not in a sharded environment. Okay. Now that we know how to create a sequence, let's learn how to actually use it while inserting the data. Now we have NEXTVAL and CURRVAL pseudo columns. NEXTVAL, the purpose of this pseudo column is to fetch the next number in the sequence. And every call to NEXTVAL generates a unique value even when accessed by different users or different sessions. This is something very useful, super useful when you need unique primary key values like invoice numbers or employee IDs or order numbers. Then we have current val, which returns the current value that was generated in the same session using the next val. You must use next val at least once before using the current val in your session. Otherwise, you will get an error. So this is how you work with next val and current val to integrate the sequences into your SQL operations. Now let's understand the concept of next val and current val with this diagrammatic example here. Now here we have the sequence flow diagram. Suppose you created a sequence starting at 280 with an increment of 10. So if before using net val, if you try to use current val, if you try to write a query sequence.current val, then in that case, what will happen? You will get the result not defined. Why? Because you have not called the net val, so the sequence has no current value to reference. After the first next val call, if you try to access the value of next val, then in that case, the result would be 290, that is 280 plus 10. Now this becomes the first actual value generated by the sequence. Now you can use current val, and after calling next val, if you try to access the value of current val, then in that case you will get the value 290. Okay, now that a next val has been called in this session, current val is available and will return the last number generated, which is 290, 290 in our case. So this behavior ensures data consistency and avoids confusion when multiple users are accessing the same sequence. So always call next val before using the current val. Now coming to the guidelines for modifying a sequence. Let's now understand the important rules and limitations when it comes to modifying an Oracle sequence. So the first point here is ownership or alter privilege. That is, you must either be the owner of the sequence or have been granted the alter privilege to modify it. And this prevents the unauthorized users from tampering with number generation logic. The second point is only the future values are affected. That is, any changes you make, such as altering the increment, only impacts the future values generated by next val. Already issued values are untouched. The third point is restarting a sequence. That is, if you want to restart a sequence from a different number, for example, from 1000 instead of the current 290, you cannot just modify it. Instead, you must drop and recreate the sequence. The fourth point is validation performed. The Oracle performs basic validation when you alter a sequence, like ensuring that the new max value is greater than the current one or checking the cache settings. The fifth point is dropping a sequence. To completely remove a sequence, use the drop statement. And this is the syntax for dropping the sequence. Once dropped the sequence, all the future attempts to use NEXTVAL or CURRVAL for that sequence will fail. So you can modify a sequence for future use, but not its past. So to reset it, recreate it, and always be very careful with the privileges. Next, we have modifying a sequence in Oracle using the alter sequence command. So here we are modifying the existing sequence named department ID underscore SEQ, which might be used to generate department IDs. We have certain clauses here like increment by 20. This means every time you call NEXTVAL, the sequence will increase by 20 instead of default 1. And this is useful when you want to skip ranges or reduce contention in multi-user environments. Then we have the next clause, that is max value with the value 9,99,999. So this sets the upper limit for the sequence. Once the value reaches 9,99,999, the sequence will not go beyond this unless it is set to cycle. Then we have no cache. This disables the caching sequence of generating the sequence values, and by default the Oracle caches sequence numbers to improve performance, but disabling it ensures no value is pre-allocated, making it safer in case of system failure, though it's a bit slower. Then we have no cycle. The sequence will not restart from the beginning after hitting the maximum. Once it reaches the max value, it stops. Then we have the clause, that is no scale. This clause prevents automatic scaling of the sequence, especially in Oracle Autonomous Database environments. It ensures that values are generated as it is without Oracle altering the increment or maximum value internally. So with this alter sequence command, you are customizing how the sequence behaves, controlling its increment, limits, caching, and cycling. All these make a sequence safer and more tailored to your application needs. Now let's talk about a very important concept related to performance and reliability. Sequence caching and why you might notice gaps in your generated sequence numbers. So firstly, caching sequence values in memory. So this improves performance. Oracle can cache a set of sequence numbers in memory to serve requests faster, reducing disk input output, and this is especially useful in high transaction environments. If a sequence is cached with cache 20, Oracle will pre-allocate 20 numbers and keep them in memory. But what about the caps? Caching is fast, but it is not perfect. Sometimes you will notice that some sequence numbers are missing or are skipped. This is normal and can happen due to few reasons. So the reasons for gaps in sequence values are: a rollback occurs. That is, if you use a sequence value during an insert and then the transaction is rolled back, the sequence value is not rolled back, it is already consumed. The second reason is the system crashes. The cached values stored in memory may be lost if the system shuts down unexpectedly and they are not recovered. The third reason is the sequence is used in multiple tables. If the same sequence is used in more than one place, the values may be used in one table and skipped in the other, which will cause the gaps. So if your application requires strict no gap numbering, like for invoice numbers or for the legal documents, consider using no cache, but be aware it's slower, or use alternative custom logic if required. Now the next topic is the sequence information. To view details of the sequences created by the current user, Oracle provides a built-in data dictionary view called user sequences. So here, as you can see, when you issue the command describe user sequences, you get information about all the columns that you have under the user underscore sequences view. So the key columns in user underscore sequences are listed here. Like we have the sequence name, that is the name of the sequence of type varchar2, and this is the size. We have min value, the minimum value the sequence can generate, the maximum value the sequence can generate, step size, that is how much the sequence increases or decreases. Then we have the cycle flag, which shows whether the sequence cycles back to min after reaching max, yes or no. We have order flag, which indicates if the sequence guarantees order in a real application cluster. We have the cache size, the number of sequence values Oracle caches or pre-allocates. The last number, the next number to be generated, useful to see the current position. There are other flags like scale flag, extend flag, sharded flag, session flag. But for now, we focus only on the important ones which is used in day-to-day work. Now, how to query sequence properties. Suppose we want to check the minimum, the maximum, the increment step, and the current value of your sequence from the user sequences data dictionary view. Then in that case, this query would be generated. And this will give you a snapshot of your sequence configuration and where it currently stands. So you can use this view anytime you need to validate your sequence behavior, especially when debugging issues like unexpected values or performance. So the next time you're designing a database and need auto-generated numbers, remember to use a sequence. It is a powerful, flexible, and a great way to speed things up. Thank you.